In these videos, I use chemicals that can cause burns and respiratory problems. If you are to replicate any of the experiments or procedures shown in my videos, please do so in a fume hood or outside, and please wear suitable gloves when handling acids. Hello everyone, and welcome to part 3 of the gold recovery from eBay eWaste series. In this video, I will be recovering the gold from all these boards. I will also be continuing with the recovery of the gold from all the ram fingers from part 1 of the series. They have been soaking and forgotten about for 2 months now, so they should be ready. I also would have been recovering the gold from the pins in this video too. But unfortunately, while not concentrating, I accidentally knocked the beaker off my work counter, and the pins scattered across the garden along with a now broken beaker. It's a little unfortunate, but it is what it is. Anyway, let's get started. Here I have a 15-liter bucket. This will be plenty large enough for all these boards. And here I have a small 2-liter bucket. You may have noticed there's some holes drilled in the bottom. The idea is really simple. What I'm going to do is place all of the small boards, such as the cell phone boards and the ram sticks, inside the small bucket. Once the large bucket is full of solution, I will be able to pull the small bucket out, let it drain, and check on the material without having to reach into the large bucket. You may have noticed I have some classical music in the background for a little ambience. Please let me know in the comments if you prefer my videos with or without the music. Here I'm going to tie a piece of string to the handle, just in case the handle drops into the solution, as I don't want to have to put my hand in there to fish it out. The solution I will be using is this old copper chloride. It is the copper chloride from my stock pot. All of the trace amounts of precious metals have been cemented out of it already, so it's great for this sort of gold recovery. The hydrochloric acid dissolves the copper oxide and allows the cupric chloride to attack the copper metal directly. Without some HCl in the solution, the etch rate of cupric chloride would be cut at least in half. You could speed up the process by bubbling air through the solution, which will cause the copper to oxidize faster. When handling significant amounts of solution, I often decide to siphon it instead of pouring it. The main reason for this is the decreased risk of spillage. As you can see, I can now easily pull out the small bucket to check on the progress of the boards. I'll leave it to soak in a safe place, and I'll be back when it's finished.
6 weeks later.
After 6 weeks of soaking, all of the gold foils should have now lifted from the boards. Let's pull out the bucket and check them over. Yep, they're done. All of the copper has dissolved into the solution. If you look closely, you can see small flakes of gold floating on the surface. I'll start filtering this off, and I'll go inside and start cleaning the gold off the small boards. I've placed the bucket into a 1-liter Pyrex jug. Now all I have to do is spray each individual board with water over the bucket, and any foils stuck to the boards will fall into the bucket through the holes in the bottom, and they'll get captured in the jug. Okay, I know this might take a while, so I don't want to bore you with it. I'll catch you when everything's filtered out. In this jug, I have all of the material that was washed off the boards. The gold is mixed in with some gray-colored chloride material, and some of the flakes are so small that they look like fine grains of sand. I have everything from the larger bucket in these 2 funnels. I'll put this material in with the other material in the jug and set it aside for the moment. Now, it's time to move on to the fingers from part 1 in the series. They've been soaking in salt and vinegar for 2 months, and all the foils have come away from the boards. You'll notice that these foils are a lot cleaner than the others, also a lot thicker. The cleaning process is the same as the other tedious cleaning process, so again, I won't bore you with it. I'll see you outside once everything is filtered. I have decided not to mix the finger foils and the board foils together at the moment. I'm going to clean up the board foils with a hydrochloric acid boil first, to see if I can get rid of some of the junk at the bottom of the jug. I've added around 100 milliliters of hydrochloric acid, and I'll let it heat for 10 minutes. This won't affect the gold. It's been boiling away for around a quarter of an hour now, so I'll let it cool off and decant the solution into another flask. The flask on the left is what I've decanted. I'm putting in around 100 milliliters of hydrochloric acid and 2 teaspoons of potassium nitrate into the jug to dissolve those foils. And while it's heating, I'm going to go ahead and test that solution in the flask with some stannous chloride to show that none of the gold was dissolved. As you can see, there was no color change. By the color of the liquid, I'd probably say it was iron chloride. I'll leave the aqua regia to do its thing, and I'll get back to you shortly. After 15 minutes, I'm still getting a very vigorous reaction. I can also still see gold foils bouncing around in there. It doesn't normally take this long to dissolve foils. There must be something else in there that is reacting before the gold. Maybe there was some steel on one of the boards and it has not dissolved in the copper chloride. I'll let it run for a while and get back to you.
1 hour later.
After an hour on the hot plate and 3 more additions of potassium nitrate, it looks as if I've managed to get everything to go into solution. Next, I'll filter it directly into the beaker with the foils from the fingers. The foils are already eating up the excess nitric acid in the solution. It shouldn't take long for them all to dissolve, certainly not as long as the other foils. After a little heating, the foils used up all the excess nitric, and everything is now in solution. A quick stannous chloride test will confirm there is gold in solution. And there it is, the dark stain I'm looking for. The solution has been filtered once already, and it still looks kind of cloudy, so I'm running it back through the same filter a second time. Filtering twice through the same filter allows all the smaller particles to get captured by the larger material that has already been captured in the filter. As you can see, the filtrate coming through this time is crystal clear. It's now time to get that gold out of the solution. I'll be using sodium metabisulfite for the precipitation. This precipitation is taking a lot of time, too. Judging by the color of the solution, I would definitely say there was some kind of contamination in there. I'll let it settle overnight, and in the morning, I'll clean it and get it weighed. So, the question was, is it possible to recover the same value of gold for the money spent on e-waste from eBay? I need 0.6 grams to break even. And the answer is no. But also yes.
Huh?
And I'm not talking about the lost pins either. So, I looked at the gold price when I got the materials, and it was around 61 UK pounds per gram, which comes to around 122 pounds for 2 grams. But, you know, since the gold price changes, if you check the top right corner, you'll see that right now it's 66 pounds and 25 pence per gram. If I multiply the gold value today by the 1.9 grams recovered, it works out to 125 pounds and 87 pence, which means that by sitting on it for 3 months, I've actually come out a whole 3 pounds 87 pence better off. If you've enjoyed this series of videos, I hope you will consider subscribing, liking, and commenting, and at the same time, why not check out another of my videos?